Hello, water managers. My name is Simon Evans, part of the Water Management Systems Division at the Hydrologic Engineering Center. Today, I'm going to be presenting the lecture on forecasting with ensembles and SWMS, part of the SWMS prospect course. This is the first part of 3 videos on this topic, and in this video, we will be covering some sources of ensemble forecasts. In this lecture, we'll discuss a few sources of ensemble forecast data and where to find more information. Next, we'll go over a few of the ensemble forecasting options that have been included in SWMS for a few versions now, including the ResSim Ensemble compute, as well as the CAVI Ensemble compute. Finally, we will explore some of the new features available as of SWMS 3.4, including the Ensemble Forecast Processor, as well as the Ensemble Viewer. So Cumulus is a real-time processing engine that provides hydrologic modelers with meteorological data. Through the CAVI extract groups within SWMS, water managers can customize downloads of observed and forecasted precipitation datasets. Cumulus can be used for other meteorological data such as air temperature and snow water equivalent gridded datasets. This resource is available to USACE users through CoreNet and CAC authentication. So one approach to introduce additional variability and uncertainty into a SWMS forecast is to include multiple sources of precipitation data. As you can see here on the slide, some of the available forecasted precipitation products include the National Blend of Models, the NDFD, the WPC, and the NAEFS. So right now within SWMS, this can currently be achieved by having multiple SWMS forecast alternatives included within a single forecast. Each METView alternative uses a different forecasted precipitation product. This example has 4 separate forecast runs, and each of them uses a different gridded forecasted precipitation product for METView input. Then each forecast then computes through HEC-CWMS and HEC-ResSim to see potential variability within the watershed. And as I mentioned, on the right-hand side, you can see that setup with the CAVI for the Russian River watershed. And then the plot there shows the variability at the inflow to a reservoir when 4 separate forecasted gridded precipitation products are used. You can see that there's the blue line there versus the red, yellow, and green. Those all represent separate precipitation forecasted products. Another way to introduce meteorological uncertainty is to incorporate products developed by the National Weather Service HEFS, the Hydrologic Ensemble Forecast Service. These forecasted flow ensembles are available at specific watersheds or specific locations within the watershed. And this is done through the work of the regional forecast centers like the CNRFC. On the slide here is an example from the Hopland gauge in the Russian River watershed in California. Right now you can see the deterministic forecast does not show much of an increase in river stage. This was for an event a couple years ago in March. However, when we switch to the 5-day HEFS ensemble forecast, we see a little bit of increase, but really not much variability in the individual ensemble traces. You can see that they're all very tightly aligned. But when we switch to the 10-day HEFS forecast, there is a wide range of possible river stages based on the meteorological uncertainty. Each of those individual lines represent an individual ensemble trace. So this reflects that there is a high likelihood of an atmospheric river event to occur in the 10-day period, but the exact impact and location, how the event would impact the watershed, was still highly variable 10 days out. Next, let's go forward a little bit in time, closer to the event. And now that the atmospheric river event the forecasted event is only 5 days out, the mean of the ensembles increased. That's shown in the green line, and this is signifying a higher likelihood of increased river stages. Going a little further downstream, this is an example of the HEFS ensemble forecast at Guerneville. Again, we'll start with the deterministic forecast, and you can see there's a slight rise at the time of forecast, but not much shown. If we switch to the 5-day ensemble forecast, the individual ensemble members all indicate a downward trend after halfway through the 23rd. However, if we again extend out to 10 days, the ensemble forecasts do a great job of showing the potential for increased river level. Now, there's a lot of variability 10 days out, but there is a potential there going above the monitoring stage, which at Guerneville is at 29 feet. So finally, a few days out from the event, you can see that the ensembles indicate approximately 5% chance of exceeding the flood stage at this gauge. So as water managers, how can we leverage this information into a forecast within SWMS? How do we include some of this uncertainty into our forecasts? So in the next video, we will look at a couple of different ways of how this is possible to do. This concludes the first part of the Forecasting with Ensembles in SWMS lecture. If you have any questions about our software, need some help, or are looking for additional training, check out these links. They can also be found in the description below. Thank you for your time.